Nature people, are you ready? This is the water cycle. Bum ba da dum. The water cycle is a movement of water between land, sea, and atmosphere. Atmosphere, land, sea. Most importantly here, we cannot forget energy is needed for this because in this cycle, our energy is the sun. This is our cycle. We start with water that has come from runoff. Then it evaporates or it transpires off of plants. It condenses into clouds, causing precipitation, causing snow melt back into runoff, and we begin the process again. Now, if you noticed, our water cycle is a cycle. So we have some coming downs and we have some coming ups. Convection is the reason for this cycle. It is the upward movement of warm air that then creates the downward movement of cold air. This is all because of density. Hot air is light, so it moves up. Cold air is dense, so it moves down. So, sunlight hits the earth, makes the ground warm, heats up this air. This air rises up, taking warm water molecules with it. That's the start of our water cycle. Then as that warm air rises, it gets colder, and this cool air sinks down to the ground where it's warmed again, creating this over and over and over again. This is called a convection current, or AKA a convection cell. But it's circular, happening over and over and over and over and over and over again. This is the convection that actually causes the wind to blow. So rising warm air creates a low pressure behind it, and the falling cold air creates a high pressure. So here's our low pressure system left behind when the air warms and rises. And as it comes back down, it creates a high pressure system. The wind that's created is the movement of air from a high pressure to a low pressure. So in this situation here, this is our cycle, we're going to get wind moving this direction from the high to the low. This is what happens at the sea. Have you ever been to the beach? So during the day, the land is warm, the sea is cold, so the air moves to the land, then it rises, then it moves back out, drops down. We have our convection current happening, and that creates a breeze because of a high pressure system and a low pressure system. And the wind is going to blow from the high to the low. So our wind is going to blow this way. All right, we have 1, 2, 3, 4, 5, 6, 7 steps of our water cycle. So here we go. Evaporation, you know this. This is when water molecules absorb energy, most importantly, from the sun. And they're going to leave both the oceans, they're going to leave lakes, and they're going to enter the atmosphere. Ocean covers 70% of the Earth's surface, so there's a lot of room for evaporated water that happens. Anytime a plant goes through respiration, it's going to exhale CO2 and H2O. So all that's part of what is leaving in that transpiration process. All right, condensation, we should know this one. Warm air is like a sponge. It can absorb so much water vapor. But eventually that air is going to cool down. And when it does that, it cannot hold all that vapor. So these individual molecules begin to stick to each other, causing small droplets that are then suspended in the air. This is called condensation, and this is how we get our clouds, and this is how we get fog. Clouds are going to form at high elevation when the temperature drops enough to cause this condensation of water vapor. So this is all condensation of water vapor. All right, then eventually our droplets of condensation are going to get big enough that they're too heavy to stay in the air, and they fall to the ground as rain. This is our precipitation. Air is cold enough though, these ice crystals can form instead, and then we're going to get snow instead of rain. Let's talk about runoff. So water is going to return to the ground as rain, sometimes snow. Some of it's going to flow across the land, coming into streams and downhill towards the oceans. This is called runoff. So when it goes all the way downhill into the ocean, this is runoff. However, only a third of the water that lands as precipitation ends up as runoff. Most of it's going to sink into the ground in a process called infiltration, where it's going to instead come into the ground. Now, unfortunately, runoff can carry nutrients, pollutants, sediments with it. So we can really stress local ecosystems when there's too much runoff. We're going to get into a lot of that later. All right, let's talk about this infiltration. 2/3 of our water that rains is going to infiltrate in through the rock. What that means is that they're going to flow through these air-filled spaces between the soil particles. It is pulled downward by gravity, moving through these spaces, and when that happens, most of the contaminants are removed from the water. This is a big perk of that infiltration. Now, there are two things that affect the amount of infiltration that happens. First is the slope, if I have steep or if I have a gentle terrain. The second thing is going to be lack of vegetation. If I have little vegetation, we're going to have more runoff and we're going to have less infiltration. However, if I have a gentle slope, I have a lot of trees, then we're going to have more water infiltrating, then that will reduce the runoff. After all this water has kind of percolated down and infiltrated, we're going to get to a point called the zone of saturation. That's this area all in here, where all the space between the particles is filled with water. There's no air left. This is referred to as groundwater. We use this for wells, we use this for drinking water. It's extremely important. It's going to move slowly downhill, this groundwater, moving through these spaces, kind of like a sponge. It's going to slowly shift and move like a sponge. It very rarely exists underground of rivers. Few cases there. And it's going to provide this vast supply of water. What keeps rivers going, that keeps springs going, that keeps this movement of fresh water happening even when it hasn't rained in many months. As I mentioned, springs are places where this groundwater is going to emerge. If you've ever been to a spring, we have lots of springs in the US, so I go there all the time. All right, and having all this water creates what we call a water table. So this water table is going to be this boundary between the zone of saturation, where we're completely filled with water, and the zone of aeration, where this infiltration. So our water table is right here, and we'll often measure the depth of that water table. All right, so quick reminder, Earth's surface is covered in 71% water. Most of it is ocean water, but the rest of it, a lot of it's in our glaciers and ice caps or in our groundwater, and then from there it's in the ground. Very little is actually in our lakes and rivers. That's all I got today. So thank you guys so much and enjoy your H2O.